Hi, everyone. Today is Wednesday, March 17th, and this screencast will go over some background information about scale models as well as what you need to do for today's lesson. So please listen and through this screencast all the way through, okay? So you have 3 goals for today. And so your first goal is to really understand and explain what a scale model is and why we use them in science. We use models all the time in science, and specifically today we're going to be looking at scale models. Okay. Then, as part of your assignment for today, you guys are going to be interacting with a scale model of the solar system to help you better understand the relative size and distance between objects in space. Okay, so again, our goal today is to really understand how large and how big space actually is and be able to compare the sizes and distances of different objects in space. Okay, and then at the very end of this lesson, you're going to show your new understanding and show what you understood after this lesson by completing the exit ticket. Okay, so make sure that you do today's lesson, but then also complete the exit ticket. Okay, so with that said, this screencast again is going to give you some background on what a scale model is, and then you will be ready and prepared to complete your assignment in your notebook for today. So, what are scale models? Now, a scale model is a representation or like a copy of an object that is either bigger or smaller than the real size of the object. Okay? And scale models, we use them to show the relative size and distance of different elements of an object. Okay? So, for instance, looking at our picture, right, that big orange yellow ball, right, that represents the sun. And of course, we know the sun is huge, right? The sun has nearly a million-mile diameter. So it's really, really big. And to wrap your head around how big even a million is near impossible, right? But if we scaled it down and we made the sun the size of this orange and yellow ball, right? Our scale model would then show how the different sizes of each of the planets, what sizes they would be in relation to this orange and yellow ball. And so as you can see, um, if the sun is this large, right, it looks like a bowling ball, then the Earth is just really kind of just a period, right? The size of a period down here at the bottom, okay? And again, that's just showing the relative size between the planets and the sun. Now, why do we use scale models in science? Right, real quick, scale models are used in many fields. I'm sure if you haven't yet, you will use them in engineering. You often use them in architecture, filmmaking, even interior design, right? This is a scale model of an interior design plan. And so they probably created this design plan just to show their clients, right, how they're preparing to decorate the inside of their home. Okay. Now, in science, we use scale models to understand the natural world around us, right? And especially objects we cannot easily see or visualize. And so typically, these are objects that are really, really huge, like the solar system, or it's going to be objects that are really, really small. Okay, so one example and models we will be looking at after this unit is a model of a cell, right? And cells are so extremely small. We need a microscope to actually look at a cells and look at what type of what makes up a cell. And even at school, our microscopes are not big enough to actually see some of those small parts, which we call organelles of cells, right? And so, but then other times, again, thinking about our solar system, right? It's so, so huge that we use a model to scale down and to help us understand the sizes and distances of all the different parts in that huge model, right? So again, we use it for very small objects like cells, as well as really huge objects like our solar system, okay? Now, one thing to understand and realize is that, right, models are not always perfect, even scale models. Scale models should definitely be accurate on the size and distance of different objects, but there's still going to be limitations to those models, and models are never perfect, right? And so looking at the picture, right, if we envision this as like 3D and seen as really a physical model, we would know right away it's definitely not a scale model, right? The planets are not they're scaled to size. Um, and the distance is also not to scale, right? But I want to show you this picture real quick because even the models we usually see of solar systems, first off, they're usually not to scale because to make them to scale, right, we either need a much, much longer distance, which you're going to learn today, or these objects, considering how large the sun is, these different objects like these smaller planets, they're going to be so small that we won't even be able to see them anyway. So one of the greatest limitations when it comes to a solar system model is definitely distance. Okay? Because to make each planet something big enough that we can see, we need a long distance. Okay? Also, just to note, right, often when we see pictures and models of the solar system, it always shows planets in line with one another, but through our studies, we know that's usually not typical, right? Each of these planets are orbiting the sun and have different orbital paths revolving around the sun, and so they are not lined up, right? But instead, they're at different parts around moving around the sun. Okay, so with that background information, right, we talked about what a scale model is, looked at two examples, but specifically we're going to focus in on our solar system scale model today, and talked about why we use them in science. And so your task today is to complete pages 11 and 12 in your Celestial Digital Notebook. And as part of those pages, you are going to be interacting with a few different scale models of the solar system. So there's a video where there's several videos, but one of the videos, they're actually creating a solar system model using a football field. So again, thinking about relative size and distance between each of the objects. And so they've used a football field to show that. And then on page 12, you're actually completing a solar system scavenger hunt by doing a digital and interacting with a digital solar system model. Okay. And one thing that's cool about digital is that distance becomes not as great of a limitation because you can just keep moving to the next page, right? Um, but anyway, like when you interact and complete these pages again, I want you to think about like just how huge space is and what are the relative sizes between all of the different objects in space. Okay? And then finally, once you finish page 11 and 12, then you're going to complete the exit ticket for today. And on that exit ticket, you're just showing like what you've learned. Okay, so it's going to be really important that you complete the lesson first and then the exit ticket. And again, if you complete the lesson and you work through the activities, that exit ticket should be a piece of cake and easy to complete. Okay? And so real quick, just one last thing. I just want to show you the two pages just in case you're a little confused. First, please disregard the date. Remember, because of our snow day, we changed it up a little bit. So again, you're just on page 11 and 12. in your Celestial Objects digital notebook, which is under Current Assignments in Google Classroom. For page 11, you're going to answer some questions and make predictions, thinking about, how big the sun is compared to Earth. And then you have 2 videos to watch to help you visualize that. Then this video on the right page is a Mark Rober video, and it's again showing the solar system model using a football field. Okay. Then on page 12, you get to interact with a digital model of our solar system. It is to scale, and so you'll click on the link right under number 1. So just click on that link. And then you have some questions to answer as you complete that activity. At the end, there's a few challenge questions, and some of those might be really hard to find. So give it a shot. But if you don't find them all, no problem. Just make sure that you have enough time to again finish your exit ticket. And you can get to the exit ticket either through Google Classroom or just by clicking on this blue highlighted exit ticket, and it will take you right there. Okay. All right, guys. If you have any questions, feel free to reach out. On Friday, we can talk during our class period or office hours. But otherwise, I hope you guys have a good day, and make sure to make yourselves and I proud. Bye, guys.